Hello, everyone. Thank you for attending the fourth session of 2022 Waste to Energy Research and Technology Asia meeting. The routes to influence policy, how to advocate for WTE in the global public agenda. This conference is jointly presented by Global Waste to Energy Research and Technology Council and Columbia Global Centers, Beijing. GWC is one of the foremost research organizations on waste to energy technologies, comprised of energy engineers, scientists, and managers from university and industry in several regions. Columbia Beijing Center is one of the 9 regional hubs of Columbia University, aiming to facilitate and promote meaningful academic exchange and research collaboration of Columbia faculty, students, and alumni with their counterparts in China and in the East Asian region. So in the final session of this 2-day conference, we will reflect on the role of academia and how it can influence policy and public agenda by disseminating reliable and credible information about WTE. So this panel will exchange opinions on how to advocate for WTE as a viable means of mitigating climate change by diverting waste from landfills and stevelands for the next COP27 in Egypt. So please allow me to briefly introduce our distinguished speaker in this panel. I think our presenter is not here yet, but I will jump to Professor Li Zark, Associate Professor with tenure at Nanyang Technological University, and Moe Saad Mansour, Professor of the Thermal Fluids, Combustion and Laser Diagnostic of Turbulent Reacting Flows, Mechanical Power Engineering Department at Cairo University, and Professor Nicholas Samlis, founder of the Columbia's Earth Engineering Center and the founder of the Global WTERT Council. Professor Chunxin Huang, Vice Dean of College of Energy Engineering at Zhejiang University. He will also be kindly serving as the moderator for this panel. So today the discussion will, talk about ways to advocate for WTE and share more of their insights beyond. So before we start, just again to remind everyone who are watching this webinar on different platforms, please be reminded that if you have any questions or comments, just share them timely in your chat or question box so we will be able to bring them up during the discussion. So now, without further ado, if I may, I want to invite Professor Samlis to start with your slides. So I will share yours from my end.
Well, before we answer the question how governments can help WTE, let's look at some of the major problems that exist for people who oppose WTE. First one is shown dioxins, so toxic equivalent dioxins. The fact is, before there were advanced gas control systems, let's say in 1975, the waste-to-energy plants, the incinerators, some people call them, they were major emitters of toxic equivalent dioxins. So I can see in this slide, you can see before activated carbon injection and fabric filter, these were the things that were instituted in 1990 about. There were 100 nanograms equivalent of dioxins per cubic meter of stacked gas, 100 nanograms. After this introduction of activated carbon injection and fabric filter, as they are shown by several studies, we heard today from one from CEVEP, but we had some ourselves from France, China, US. They dropped to 0.02, from 100 to 0.02 nanograms, 5,000 time reduction. But the people in 1980, they had a good reason to oppose waste to energy, because at that time, there were high emissions of dioxins. 1980. But the perception has continued. And I found that myself when I was working for IPCC, the 15th report of IPCC. People were still talking like there were large dioxin emissions. And I pointed out, and in that report, we say so. Just another idea to give you about that is in the US, America, in 2012, the total waste-to-energy emissions from 27 million tons of solid waste combusted were 3 grams TQ. What were the landfill gas emissions, dioxin emissions at that same year? They were mostly from landfill fires, which happen without premeditation. They're spontaneous. The high temperature created in a landfill and fires start. And at that year, the landfill fires in the US emitted 1,500 nanograms. Grams. You know, it's 500 times as much. So this is does not exist anymore. And I showed that dioxins because this is the most usually mentioned emission. From all other emissions have followed the same route. Next slide, please. Next. Elena. Thank you.
Oh, there's seems like some delay. Sorry, go ahead.
Yeah. What is the major greenhouse gas benefit of waste to energy? We completed a study 2 years ago, actually 2021, where we examined about 1,100 landfills in the US. And the estimated methane generation at landfills in the US were 0.05 tons of methane per ton landfill. This publication is available and we can send it to anybody who wants to see it. 0.05 tons of methane per ton landfill. So if you take this number and you consider the 20-year horizon for methane in the atmosphere, which IPCC has established to be 80 tons of CO2 per ton of methane. So if we take the 0.05 tons and multiply by 80, we come to 4 tons of carbon dioxide per ton landfill. And to give it a global perspective, since the current global material landfill is about at least 1.5 billion tons, times 4, you have 6 billion tons of carbon dioxide. 6 billion tons of carbon dioxide are 15% of the global CO2 emissions, which are stated to be 43 billion tons. So it's an important part, 50%. Next slide. Next slide, Elena. Well, I do
you
it.
See it?
Yeah.
What about now?
No, there. So, all right. We talked about dioxins, and there can be other things mentioned against the waste to energy, but they can all be discussed, and they've been discussed in the 3 previous sessions. No, the next one. Elena, the next one. Oh, yeah, there. So what is the remaining major obstacle to waste to energy? Why, if waste to energy is as good as it has been proven to be, why is it not used more extensively? The reason is that it's a larger capital investment per ton of solid waste. Larger capital investment. And I'm showing here, we estimate $50 capital investment per ton of waste for waste to energy. What does this mean? If the plant is 1 million tons of solid waste that many cities produce, 1 million tons times 50, it would be $50 million. Compare this with landfill, which is $20 for a sanitary landfill. It's 2.5 times smaller. So it's a much better business for anybody to go into landfilling business in the short term than go into waste to energy. It costs more money. Of course, one of the reasons is a waste to energy plant is built for decades of years, for 20 years, 30, 40. We have plants in the US operating for 50 years. Well, the landfill, you build it as you go along. You don't have to put the capital in the front. So there's a $30 differential in capital investment. Now, cities and countries who adopted waste to energy, and there are many of those, there are at least 1,000 waste to energy plants existing, decided that the extra $20 of US investment per ton of solid waste was worth the environmental benefits, which is the greenhouse gases, recovery of energy, metals, and materials, and conservation of land. And just to get one example, before we showed 4 tons of CO2 per ton. What is the cost of capturing carbon dioxide? Many efforts are being made around the globe to get capture systems up. None of them has worked completely as yet, but the most promising, it shows at least $60 per ton of carbon dioxide. So we're talking about an extra cost, an environmental cost of $200 per ton, and yet we don't spend the extra 30 that's required. Next slide. Next.
Did you see it?
Yeah, I see. I missed the top of this slide. The top says, excuse me. I make a prediction that during this century, landfills are going to be phased out by waste to energy plants. This is as sure, in my mind, as the replacement of horse and buggy by automobile. It took some time, for an automobile to replace horse and buggy and the horse-drawn cart. It will take some time for waste to energy, but it will happen. Because as the earth and the oceans of the earth degrade, and degrade because of what? Because solid waste discarded indiscriminately, municipal, regional, and national governments will give the same priority to processing post-recycling solids as to wastewater treatment and to water and electricity supply. For wastewater and electricity and water, we don't expect private industry to step in. It's done by government. China, some of the European EU countries and the UK had demonstrated already that government policies can phase out landfilling by supporting waste to energy. How? In China, they had for years a $30 credit for waste to energy electricity per ton, $30 extra paid to waste to energy plants. And that led to the hundreds of plants built in China. Or a landfill tax, it doesn't show because your pictures are in front, a landfill tax per ton landfill. That has paid off. It already works in many countries of the European Union and in the UK. And it's another way the government can step in and make sure the right thing happens. Thank you. Thank you.
Thank you. Thank you very much, Professor. In China, Professor, actually we are landfill site to reclaim the land for other purpose. And I have got a project with Professor Li Xiaodong this year, and which was supported by our local government to dig the landfill waste and to separate the waste, and some organic stream will be burned in the waste to energy plant, and then the land will be reused.
Yeah.
Hello?
Yeah, I hear you.
Yes.
Helena, can you hear us?
Hello?
Hello, everyone. My name is Rebecca Bass. I just joined in. So basically, I will move the floor to Professor Greg. So if he could share his presentation. So let me know if you can share your screen, or I will share it from mine.
Yeah, let me check that.
Okay, thanks. Okay, great. I can see now. If you can put it on.
So,
okay.
Is it display mode?
No, it's. I think you have the two screens at the same time.
Oh,
yeah.
How do I change that?
Yeah, from display setting at the top. No, the next button to the right.
The thing is, Zoom actually takes the toolbar. Cannot click on that one.
No, the second one. It's a display setting at the top.
I can share from mine if you want, Professor Greg.
If that would be possible, please do.
Okay, fine. If you can stop screen from yours. Okay.
Okay.
Stop. Okay, perfect. Good. I'm gonna share my screen now.
Okay, perfect. Sorry for that, everyone. Good morning to those in Asia. Hello to everyone else. My name is Grzegorz Lisak. I work and live in Singapore at Nanyang Environmental Water Research Institute, which is affiliated to Nanyang Technological University. And basically, I have a pleasure to lead Residues and Resource Reclamation Center that deals with all the waste management that relates to the issues in Singapore, as well as the region, and obviously those relate to global issues in waste management. So taking this opportunity, when we will be talking about the policy, first I would like to introduce of what we do in the center. Very briefly, just a few minutes, but this is important to actually understand of where we at in Singapore, because Singapore is a very specific place in waste management developments. Okay, because Singapore is very small, means that we do not have the land for a landfill in very traditional terms. The only landfill that exists in Singapore is called Semakau landfill. It's an offshore landfill. It's an island that stores ashes from waste to energy plants. And that's it. We don't have other place to store waste. And to be honest, that landfill will also end its life in about 10 to 15 years, which puts Singapore in a very particular spot. We now think about technologies of how we recover the energy from waste, but also how do we recover materials from waste? Because we actually have to save not only the space, but also resources. So Singapore is a small country, as I mentioned, no much of natural resources. Most of the food and other products are being imported. So naturally, we are looking how to revert some of those resources that are being brought back into the system. So let me start with our activities. In this slide, you can see I apologize for quite busy slide. Nonetheless, basically showcase of what we are dealing. So my center works on waste to energy, waste to materials, and contaminated site remediation and assessment. So waste to energy in Singapore landscape, we are already at the level of incineration, which is commonly applied technology. All municipal solid waste are being incinerated, and ashes end up in the landfill, as I mentioned. So actually, our collaboration with the government is to look for more advanced technologies beyond incineration that would possibly complement incineration. So we are not talking about phasing out incineration as such, but develop different methods that possibly could complement incineration. And this is where our work on gasification comes in place, as well as pyrolysis. So on the left-hand side, you can see our work on decentralized pyrolysis system. We work with our industrial partner to basically develop a technology at hand for waste management in
hello, Professor.
Yes?
We can do the CEO slide.
Oh, Reda.
I can see it.
Can you see it now?
Yes, yes.
Okay.
Yeah.
I'm still on the first page of your slide. Should I move to the second one?
No, it's fine. You still,
Okay.
yeah. So pyrolysis is being one of those advanced methods. We know now that recovery of materials from waste will be crucial in the near future, especially such resources as hydrogen, and gasification and pyrolysis can play a significant role when it comes down to recovery of hydrogen from waste. So quite a lot of our work is basically done on recovery of materials in any type of forms, and gases and energy at the same time. So we think that waste are just basically misplaced resources, and we can revert some of them back, if not all. So another work on gasification, we are working on recovery of incineration bottom ash and application of that ash for construction material. In Singapore, this sort of concept gained such a traction that soon we will see ashes being diverted from the landfill and used for the construction. And how we do it in Singapore is basically we don't call the new product a waste. We basically brand it. We brand it so that right away from the start, it does not reflect that perhaps sometimes negatively understood idea of waste, what waste is. So for Singapore, the incineration bottom ash is branded as new sand. New sand because it is basically serving a replacement for traditionally imported sand. And as you may know, in Singapore, we do a lot of land reclamation, as well as it's also intensive in terms of the construction industry. So having that additional resource in form of the ash is just perfectly fitting in what Singapore needs. Let's not forget that actually all the plants, waste to energy plants, that generate a relatively highly concentrated stream of CO2. And that gives us opportunity to actually tap on any sort of CO2 capture technologies, and even connect them with another system which is called desalination in terms of water recovery from seawater for further recovery of the materials. So what I mean here is that basically we can capture CO2 in various ways. Here on the slide, I just show one case scenario of so-called calcium looping system in order to continuously capture a high concentrated stream of CO2, but also another way of capturing CO2 through mineralization process. And this is where we can recover carbonates from desalination brine using
Recording in progress.
using the CO2 capture from flue gas. So in flue gas, you get between 10 to 15% of CO2. So obviously, there is a huge traction, not only in Singapore, but worldwide, to capture the CO2 for various purposes. And waste to energy can provide that sort of stream. We know how difficult it is to capture CO2 from air, and we need to tap on more concentrated streams. So even in our facility, as I will later show, we are now running 2 pilot projects in order to realize that capture of CO2 from waste to energy plant. Next slide, please. Aside of that, some of the work that we do on gasification, which really closely relates to Japanese provider of the gasification, so-called high temperature slagging gasification from JFE Engineering, we perform studies on how to upgrade the syngas, not only for energy generation, but also for possibly chemicals synthesis, because syngas that comes out from gasification process can serve a good feedstock for chemical synthesis. And naturally, before we do that, we have to simply purify the syngas, because when it comes from such complex feedstock as municipal solid waste or sewage sludge, actually it is basically contaminated. So our work here is on upgrading the waste to energy processes in order to generate this high quality pure syngas that could be used for chemical synthesis. So what I'm trying to say in terms of what Singapore does is that incineration is established already, and it's a basic requirement for treating our waste. We do it for energy recovery, but more likely for saving the space, so volume reduction. But we are on that second stage, is where not only energy recovery is a priority, but material recovery is something that we are more interested in. And this is what I think will happen everywhere in the world in the future. Landfills simply cannot exist because the resources are lost. This does not fit into what we call circularity of materials, circular economy, environmental processes, environmentally friendly processes, and so on. So that linear treatment of waste is not possible anymore. And sooner or later, countries will follow the route what Singapore does. And we understand also that everyone is in different place on that road. Singapore obviously is being advanced. We are now going forward and looking for more advanced technologies. And some countries perhaps are at the beginning of the road, where naturally incineration is the first step because it treats the bulk of the waste and it gets the energy out of the waste, volume reduction, management of resources, management of pollutants, and so on. So next slide, please. So this is what is the current situation in Singapore. We generate about 6.94 million tons of solid waste. This data is from 2021. About 5.12 million tons come from non-domestic waste, and about 70% of that waste is being recycled. Then 1.82 million tons we generate of domestic waste, and only 13% of that waste is recycled. So anything that is not recyclable ends up in the waste incineration, in the incinerators. We have currently 4 in operation, which serves for treatment of all our waste. And that ash that is then generated, it's about 600,000 tons per year, ends up in the Semacao landfill, the picture down below. And you can see that we are getting full. So that gets us traction to look at recovery of ashes as new sand as well. So we already been testing. We are obviously in that domain, we are behind Europe. Europe has the utilization of ash for years already, while in Singapore, we are getting to the point of standardization of that material for the use in construction. So our pilot project that was done on constructing a road, and the ashes were implemented in the sub-base, has been completed, and the results are very promising. So we do hope in a year or so the other construction projects will start when ash will be used instead of sand. Next slide, please. Except of what Singapore does on waste management and incinerators, next step for Singapore is basically to integrate all the treatment processes that serve our needs all together, so that we tap on basically benefits of each other, and we avoid transportation. We are able to treat all the waste in one place. So we integrate all the waste-based management processes all together. So in the near future, we will have an integrated waste management facility, which basically gets us all together in one place. So recyclers will be there. Power will be generated from waste. Wastewater will be treated. Then naturally digestion will be performed, producing biogas, and the sludge will be treated by incineration. So altogether, all the waste management processes will be based in one spot and avoid all the transportation, management of waste. So Singapore is in this stage of development where what I would refer to what Professor Temalis said yesterday, every one of us has a right to clean water, every one of us has right to get energy, and waste management is that right for everyone. And Singapore understands that very well. And this is why so much attention is being put into integrating all those processes together. Next slide, please. So talking about next generation waste to energy, I did mention that we ourselves, we operate a plant, a small plant, and that plant is a JFE technology, is a high temperature slugging gasification. You can see in the picture in the middle. We treat 11.5 tons of municipal solid waste per day. That waste mostly comes from NTU campus, from our own campus, and some few other locations. So it's a good representation of what municipal solid waste is. And in this facility, basically we test all different type of technologies that relate to waste to energy. Those could be related to, for example, application of different feedstock, which is municipal solid waste, industrial waste, incineration, bottom ash, or sewage sludge. Then we test possibly other type of fuels that could be fed to the gasifier in terms to intensify the process. And we look at biomass charcoal, biocoke technology, which is totally different to what commercial plants use. In Japan, these plants are being applied commercially, and they use coal coke. In Singapore, we cannot use coal because it is considered as a dirty fuel. So from the beginning, our technology adopted biomass charcoal. And we are now the only facility that operates on greener type of auxiliary fuel. Then naturally, we look at other resources that could be recovered, and this technology offers us to get so-called slag instead of ashes. So basically, those would be vertified ashes, but that slag again looks very like sand and can be easily applied in a construction as a sand replacement. So again, that term new sand is being accepted as a name, official name for the slag from gasification. And this form of waste can already be applied anywhere in Singapore. And on the right-hand side, you actually see ENV Plaza. So this means environmental plaza. This plaza has been constructed using our own new sand, and it is in front of environmental building where all the environmentally related government bodies reside. So environmental agency or public utility board that deals with water management. And this gives the confidence of to people, a showcase to people that this material is safe. So naturally, the basic requirement for any advance of policy is to be closely collaborating with government bodies and to educate so that it starts from the top and radiates down of what is acceptable way of waste management. Next slide, please. Okay, so that's the end of my short talk, and I'm looking forward to the discussion. Thank you.
Thank you, Professor Lee Zuk, for this very detailed introduction about Singapore's situation. And I think the slides are very rich. And fortunately, we're looking at from the Zoom end, so it's very clearly in different column. So I want to double check if Professor Mansour want to give some comments before we enter into the panel discussion, or we can.
Yeah. Maybe
Please.
I can give you some. Yeah, I can give you some introduction about the situation in Egypt. You know that Egypt is about more than 105 million population, and we started lately in this waste to energy business at the governmental level, although we had some attempts on local efforts to use waste for some sources, like people building a chicken farm to convert waste to energy for electricity. And government now is trying to impose some law and some instructions for the use of waste to produce electricity. I mean, let me talk about waste to energy business from the point of collaboration between academia, government, industry, investors, and these kind of connections, because actually in order to apply waste to energy in a country, we need to look at the different sectors. So from the academia, we started maybe more than 15 years ago or 20 years ago at universities to work on this waste to energy, like using gasifications for converting this waste to syngas, and using in some places direct use of the waste for heating and for actually supporting some industry. In the distribution of waste in Egypt, we have agriculture waste, which is actually one of the major problems in landfills as well, because people used to burn agriculture waste open in the atmosphere, and that was really creating a large source of pollution in the city of Cairo. We call it the black cloud. In the October, September, November time period, And it was really a huge effect. And then the government realized that we have to move on helping the farmers to replace this open fire to some other, like waste recycle, or using the waste for electricity or for some heating purpose. At Cairo University, also at the American University in Cairo, we started actually to develop this waste for gasification process. We succeeded to build a mid-size scale of gasifier. And as you know, that Egypt now is hosting this COP27, and we really hope to disseminate technology and trying to get the world attention about this green environment. Like we hope that Sharm el-Sheikh will be a green city that actually can implement different technologies for the waste to energy. So in my opinion, that I think at WTE centers around the world, we are just new starting in Egypt. We just starting about a month ago, and we're still in the process to get our paperwork officially from Cairo University. So I think the link between the different centers and the sharing technologies between us to start actually be implemented in Egypt and worldwide. This is, I think, one of the main important tasks that, to me, it should be very helpful for our center and for the others. We have some other attempts in other different universities, like Ain Shams University is also one big university in Egypt, or in Cairo. In Cairo, we have Cairo University, which is about more than 250,000 students. It's a really big university. And Ain Shams is about the same size. So we're talking about maybe 500,000 students in the same city injecting this idea of waste to energy, and students also, they love to work in this field of research. So I mean, I did not have much slides or any preparation. I hope that I could bring something for you, because the time difference, I was expecting that to be 3 p.m., but it turns out to be 3 a.m. So I hope that for us it would be a good start, and hopefully to meet with you physically in Sharm el-Sheikh in November in Egypt, and maybe we can have another agenda together, how to work together in order to apply the best technology for different countries, because each country has its own waste management system. And if we can come up with waste to energy management system that can be implemented everywhere, that would be great. Thank you very much for invitation.
Thank you so much.
Looking forward for collaboration.
I think COP20. Thank you. COP27 will definitely bring good timing, and I hope both of us at GWC will join forces with you and explore how to gain the world attention for this WTE issue. Yeah. So now I will pass the microphone to Professor Huang to lead and facilitate a new round of discussion with the panelists. Thank you, Professor Huang.
Thank you very much, Helena. And it's not leading; I think it's just a discussion. And thank you very much, Professor Smith, and thank you very much, Professor Groja, for sharing your information. And I think waste to energy is very important. And professors, we have working with Professor Smith for, I think, over 10, maybe 50, since 2012. It's almost 10 years. And I really hope you can come to Hangzhou again. And he has supported us a lot, especially on waste to energy, and how can we wipe out landfilling, and especially to improve the influence in waste to energy to the public and also to the government. And then China is developing very fast in waste to energy, especially in the last 2 or 3, maybe in the last 10 years. And some countries are still talking about landfilling. According to our government, especially for Hangzhou, like Shanghai, I think in the next 5 years, landfilling will be wiped out. There will be no landfilling for fresh waste. So, and also our government put a lot of resource and energy to reclaim the landfilling site. And I will show you several slides about one of the projects we are working on to dig out the landfilling waste and to reuse. And let me see, how can I share this? Sorry, I have not changed.
Yeah.
Yes, can you see the slide?
Yeah,
we can translate.
Yeah. Sorry, I don't have to translate it into. No. Is it work for you?
Not yet. You quit the sharing. Can you try again?
Okay. Is it work now?
Yeah.
Okay.
Yeah.
So here is the picture. We are. Let me see. Here is a picture I would like to share with you. What we are working now. Not only we want to build a more efficient and stable large waste-to-energy plant, we also working on the landfill site reclamation. Here is you can see here. I would like to see here. Here, you can see here. And we are using very big machines to dig out the waste from the landfill site and separate it into different streams, like some soil and also organic component. Organic component will be sent to waste-to-energy plant, and the soil will be reused, and also some inorganic materials will be used for road constructions. And this project is supported by our local government, Zhejiang province. It's approximately 4 million RMB. And also several companies will be involved, and they will be responsible for building the landfilling site project. It's approximately 20 million RMB, 20 to 25 million RMB for one small landfilling site. So why our government want to, next slide. Here is the machine we are using. This one. Here is the machine. Can you see this?
Yeah.
Yeah. Here is the technology we are using. For example, the waste will be digged out, and then it will be separated, and the different stream will be separated out. And here you can see the inorganic and some soil, which was used to the landfilling covering layers, and also metals, and also waste like aged waste, some plastics and also some papers or wood materials will be submitted to the waste-to-energy plant. And some of the soil will be used for the agriculture usage. This is the project our government is doing now. And here you can see we are doing some tests in big waste-to-energy plant. This is a fresh waste and aged waste, which was burning in the waste-to-energy plant. And here you can see the burning out materials. So and also from the waste you can see there's a lot of the plastics like rubbers. So we are using pyrolysis technology, big facilities, and to cover the waste plastics into oil and some of the gas. Well, this oil will be used as assistant fuels to some industrial boiler, and also the gas will be used to maintain the pyrolysis system. So, sorry, and several slides. This is a big project our university and the government was working on. So I think before 2025, all fresh waste, especially in Hangzhou, where there will be no landfillings, and only fly ash will be stabilized and submitted for landfill. Another important thing is our government is want to improve the monitoring of the all waste to energy plant. The monitoring, especially not only about pollutants but also about the carbon dioxide, and our government is responsible for the carbon neutral project. So a lot of the research project has been carried out on these areas. And also, Professor, some of the country, especially Professor mentioned about the dioxin. Dioxin now in China, for the waste to energy plant, especially built after 2010, the dioxin is controlled pretty low. But the big problem is when the waste to energy plant is starting or shutting down, the emission of the dioxin is pretty high. So our university is working on to control the unstable operating period, the dioxin emission during the unstable combustion times. A lot of things, and also a lot of project and money have put into waste to energy systems. And I think a lot of the developing country may learn from the experience of our country, especially some countries do not have a waste to energy yet. And that's I want to share about the information. And also, Professor Grosjean mentioned about pyrolysis, and also our university also doing some pyrolysis system, especially on the waste to plastics. And because waste plastics, it is possible for waste plastics to be converted into like oil and also like gases. But the gasification is very difficult because the waste usually the material we are facing is a mixed biomass and the plastics and all mixed together. If you want to get very high quality syngas, the raw material must be the quality of the raw material must be controlled very well. So otherwise, the syngas is very difficult to you need to put a lot of the energy to clean the syngas. Then it can be used for further usage. So we have 2 or 3 gasification projects. It is under operating in China in Lishui province, in cities, but it is not so stable. It's sometimes like a staged combustion. The first stage is we control the air injector to reduce the equivalence ratio. And then there was a post-combustion chamber. Then the syngas is burned. So it's more like a staged combustion. So not a pure gasification, not like the coal gasification systems. It's a little bit. So you will meet a lot of tar in the syngas. So tar is very difficult. We have used a lot of catalyst to remove the tar, but it's not. In lab, you will get very good results, but if you want to scale up, it is very experience. And I have never been to Egypt, so I hope I can have a time to go carry on. Maybe with Professor Solis, and so we can share some information on that and the experiences there.
Yeah, thank you, Professor Huang.
Hi, Professor.
I was thinking, when Professor Mansour spoke, that it would be very good in the next COP 27. It would be very good if waste to energy could be one of the items to be discussed. I wrote recently to Jeffrey Sachs, who was very much involved in the Earth Institute, and his meeting, I think, with the president of Egypt, asking if he could help. But maybe Professor Mansour can help to make waste to energy one of the aspects to be discussed. We talk about 15% of the greenhouse gases, 15%. And it can be done at a fairly low cost in comparison to the other things. If it can be done, Professor Mansour, then I would personally, and GWC would make sure that some key people from around the world participate in discussions in Egypt, including Professor Huang, who he didn't mention, but he's the new chair of the Global WTERT Council.
It's really my great pleasure to go.
I'm a goner, and he's a camera.
Yeah. Well, I mean, I like this idea very much. If you can send me some piece of paper that includes some information that how important to have this WTE in the sense, so I can move from WTE International and go to the president's chamber or whatever, people there, trying to convince them to be included into the next COP in Sharm el-Sheikh. And that's, I think it can be done.
I will send you. Thank you very much. I'm saying it's 15% of the gases if you take the 20-year horizon. And, many people say this is going to be a critical period, 20 years.
Yeah.
Already we have, in Greece, I'm from Athens originally, there's 35 degrees today. Can you imagine? In May. What's going to happen in August? I don't know.
Yeah. Are you from Aachen?
Athens. I was born in Athens.
Okay.
Yeah.
Athens.
Professor Lizak, very much interested. As you know, we have been involved in the discussions in AE in Singapore with regard to the utilization of ash. And one of our students, a Chinese student, has graduated with a PhD this last year. And she worked on ash. And I would like her I will put you in touch with her because to see whether her results on stabilizing fly ash and what can be done with bottom ash may be of interest to you.
Happy to do that. I also would like to say this is a great platform to advertise some positions. We have a number of open positions in waste to energy and waste to materials. So please do send us some good candidates.
Yeah, she would be a very good one. She doesn't want to go back to China right now.
It will be very difficult now.
So, Singapore would be great. Of course, we would miss her at Columbia. She's a postdoc already here at Columbia, because working with Professor Bourtzavos. All right.
Okay.
Well, dear speakers, I just want to jump in because we have some questions from the audience, and I want to share with you some of them. So someone asked, although this conference has presented several statements and examples demonstrating the benefits of waste-to-energy technologies, I do not believe there is a consensus regarding this. May this be one of the reasons why waste-to-energy is not on the global public agenda in dealing with climate change?
There's no consensus. It's like climate change. There are some people, including ex-President Trump, who thought that the greenhouse climate change is a myth, but the majority of people know what's what. It's the same with waste to energy. Professor Huang and I said the same thing today, that landfilling is to be phased out, will be phased out, because the economics and environmental aspects are all compelling. Now, but we need a global forum like the COP27. It would be good. Let me tell you my experience when I worked with IPCC. They invited me to work on the waste management. And I found some people there who had not been in waste management. They were environmentalists. They were totally against waste to energy. But when we discussed why they were not for the right reasons. They were talking about dioxins or that it replaces recycling, when in fact this conference showed that recycling and waste to energy go hand in hand. So it's a very good question. If it's such a good thing, why there are environmental organizations who still oppose it? Some.
Yeah. There is another one. Some news report that EU has decided that waste to energy incineration should be excluded from financial support, since it is now recognized that it opposes the transition towards a carbon neutral and circular economy. This will make it very hard to incorporate waste to energy as a solution to climate change in public agenda, isn't it?
Well, I don't want to be the only one talking, so I'm going to let somebody. We don't have the CEVEP today. Today, there was a lady from CEVEP, Confederation of European Waste to Energy Plants, who spoke eloquently how waste to energy is progressing. It's not true. It is true that at some point the European Commission spoke adversely that waste to energy somehow conflicts with circular economy. But this was on the mistaken idea that everything can be recycled. You know, I brought the example of the city of Milan in Italy. They have done the utmost to recycle and compost. They have 5 streams of recycling. They have trucks picking up. Even so, 48% are recycled or composted. 52% cannot be recycled or composted. So what are you going to do with that? It's almost like, an ostrich putting their head in the sand. And it has been like that in New York, for instance, for several years, until recently, New York City. There were some people opposing, although they use waste to energy right across the river. But even in New York, it's changing because there's no way to recycle everything. There's no city or in the world.
Yeah, I agree with you, because actually I can give you our model in Egypt. I mean, up to 1960s, 70s, the waste management was really very efficient, even though we could recycle maybe more than 50%, but we still have something like 20 million tons of waste cannot be recycled, and they have to go in landfill, and really we had some problems. And it's really time to bring this up to the agenda of the world. I mean, we need to look at waste to energy. That's why when I'm saying I need a paper from this organization, so that will be quite convincing that we are as 23, 24 countries working on that field. And we present this paper in the COP27 to convince the world that this is a topic that should be handled by the governments everywhere.
I think we should do it. As a matter of fact, listening to the last 3 sessions, I was not a participant, but I listened. I had this idea that there should be a white paper coming from this conference where the best impressions and ideas of people in this conference. Because you mentioned, Professor Mansour, 20 countries or something. But in terms of populations, we have India and we have China.
Yeah.
The US. We makes up a lot of countries.
Yeah.
So
and we have Singapore.
Yeah.
2 million people. So 2 billion people. So if you, Professor, do you remember we visited Hong Kong? Hong Kong are doing waste separating, recycling. It's like a small house, some waste and separate. But when you are facing big city like Shanghai, like Hangzhou, every day, or like New York City, every day we have like 10 to 20,000 tons of waste. How can you recycle all this mixed waste? I think it's different stage. Maybe in the future, all waste may be recycled. But currently, waste to energy is most efficient and the most environmental friendly technology to treat all this waste.
Let me ask Nicholas something, please. These numbers of $50 per ton and $20 per ton, does it include also the energy produced and the how much energy that can get back from these $20, or that's only based on technology?
Yeah, no, the $50 to $20 is capital investment. The charge to repay. Suppose that you borrowed the money from the bank and you have to pay at a reasonable rate of interest. You would need $50 per ton.
Okay.
It assumes, and actually, if you consider the energy benefits, it assumes that the energy benefits more than match the operating cost of a waste-to-energy plant is higher than a landfill. Not by much, because you need 50 people, let's say. But you have the energy level. And so in many countries of the world where the electricity is expensive, it can be an economic measure privately. But what we say is that if it's not, governments have to play a part in it, a private-public partnership, because the government is supposed to look into the long term. If you have a mayor of a city and he's there for 2 or 5 years, he may opt for landfilling. But the country lives for hundreds of years, and landfilling is not sustainable. So the country has to participate in those cases where the electricity cost, the price of electricity is not high enough. I don't know what it is in Egypt, but today we heard from one presentation which was $135 per megawatt. That's more than enough to pay for a waste-to-energy plant.
Yeah, that's why our government actually is trying to implement tariff for waste-to-energy, and it's starting, I think, last year, and it will continue because they see that it has some benefits of actually converting this waste to electricity.
I will send you, I think Reda has already, a chart which shows the landfill tax imposed by countries in the EU. They impose the landfill tax to force people to think there's another way doing it, And in UK has resulted in many waste-to-energy plants being built in recent years, in UK and Ireland and so on.
Yeah, well, basically, thank you so much, all speakers. I have a question here, regarding the policy. Policies is very important to develop and advance the waste-to-energy technologies. And how do you think academia could help governments, exposing the experience from Singapore, for example, China, they are very advancing in terms of the waste-to-energy, to showcase example, for example, to the government of Egypt, and also how to disseminate credible information, to overcome all this, misunderstanding about this waste to energy technologies and incineration.
Maybe let me take this question. It's very important to have a good relations between the academia and the government. In Singapore, we are very close, not only because we are a small country, but because Singapore is quite technology forward country, which means that it goes a little bit beyond of what is considered to be a standard, as the size of the country pushes us to be more efficient, conserve the land, even get the land back from the sea, so land reclamation projects and so on. So academia is very much incorporated in what government policy is going to be set in the future. So we serve here as a platform for unbiased validation of any sort of technology that Singapore would be considering to implement in the near future. And this is exactly what was done with the waste to energy in Singapore. Obviously, the incinerators exist for a number of years already. We are well advanced, but we don't stop. The government is still looking for even more efficient ways to recovery. We know the recovery of material is going to be a next thing. So landfills and fresh waste landfilling is not an option. So ultimately, we are even thinking beyond typically incineration. So that sort of connection between the government and the academia gives you the platform to advance faster on that technology adaptation in the country. Obviously, that may not work in other countries, so I cannot really speak for that. But for Singapore, it's that close relationship between the government and academia that drives the implementation of new technologies. Test bedding is usually supported of any sort of advanced technology that would be promising. The project which I showed you in my slide, that near full scale facility that we have of gasification, it's actually funded by National Environmental Agency in Singapore as a part of validation how this technology could serve Singapore even better, complement incineration, and so on. So obviously, having a well-functioning government that is eager to listen to the science and what is reasonable and what is scientifically sound is very important. Because only then, when you get the government understand well what is the waste to energy, you actually can make the other things happen in terms of educating people, getting the acceptance from people, and ultimately kind of fitting it in the existing scheme of waste management in that particular location. Because it is not to serve as replacement of other technologies, it's to actually benefit, for example, recyclers, benefit people, so kind of fit into that sustainability model and growth. So that's particularly about the Singapore. I know other countries may not be going the same route. And I would like to mention again, reinforce that although waste to energy as globally should be promoted and should be driven by science, how we get there, it really depends on the individual country's pace and individual country's situation, because we are not the same in terms of economic advancement, and it would be really hard to ask a developing country to really go for advanced waste to energy processes. So there is natural progression in waste management that we need those countries to follow, and only then, we can somehow reach to the end point in what we think is necessary in terms of energy recovery and materials recovery. Thank you.
Yeah. Professor,
let me. Okay, please.
Yeah. Oh, I'm sorry. I agree fully what you said, Professor Lizak said about the need for the academia to connect with government and with the industry. In our case, the United States, when we started on this, we started because we were the only university at that time, major university, concerned with waste management. At that time, EPA was not even thinking about waste to energy. I mean, in their webpage, they had nothing about it. But little by little, it worked out with EPA. Of course, a country can be very complex, especially the United States. You have state government, you have federal government, and so on. So it can only be done by steps. It's not like Singapore, which is a fairly smaller place to deal with. But the reason we set up WtERT and the reason why we start WtERT at different countries is to exactly do that, for the academics to take the lead, to bring together industry, get some support from industry also, financial support, and then deal with the government, have industry and academia agree on something, and then move it on to the government, to the regional or federal level. It's not an easy thing, I must say. United States, we have only been successful to have a couple of waste-to-energy plants. China has been very successful with hundreds of new plants.
China is a very good example, I think, for a lot of countries. 30 years ago, the waste-to-energy rate is almost zero in China. And after 30 years, our academics provide a lot of support because the composition of the waste in China is very different from that of the European, from Japan, and the United States. So when our university starting to do energy research, our government put a lot of the fundings. So, and also we got support from industries. And then we developed a lot of new technology to make the incineration more stable and the burn out more completely. And then after 30 years now, a lot of this, especially in the coastline cities, the waste, almost full fresh waste are all burned and incinerated for energy recovery. So I think in current stage, the government especially should take very seriously about the waste management, because for bigger cities, very large populations, and if the waste is not managed well, and especially big volume of the waste was there, it will make the public, it's more bad for the public. So the relationship of the government, the academic, and also the industry should be very harmony. It's like philosophy. I'm sorry, and in China, our central government, the local government, and has put a lot of the fundings to support the academic. So we carried out a lot of the research work. For example, we have pilot systems. Professor Simmons has come to our university. We have very big pilot systems. And by using these pilot systems, we can get experience. How can we improve the technology to make the public know waste-to-energy is clean, efficient, and the best way to deal with the massive waste. Sorry, I have to answer the phone.
Yeah, let me
add something.
Yeah, let me add something. I agree with actually Professor Lizak and the other speakers about how can we approach actually government. This is it depends on the country. I mean, in every country it has its own situation. Maybe Singapore is a lucky country that actually there is a very strong connection between government and academia. Private sector also is another very important in Egypt, because if you can convince private sector to best use waste for energy production, this is also another way for implementing this. Let me actually propose something for our community as WTE, that maybe if we can have some kind of bulletin every couple of months or something, like to disseminate our, achievements or achievement in different centers. And something like this scientific journal, but in a more applied form, that we need to say success stories in different places and technologies development, etc. That will be very helpful, actually, to say this is a waste to energy. It's coming up and it should actually be part of the world.
Yeah, definitely. Thank you so much, Professor Mohin. kudos for you. I know it's very early, in your science zone. And basically, this is something very important, that it is important to bring bridging the gap between science and key decision makers. And definitely, I personally learn a lot from these 4 webinars. I was very impressed by how China, the academia and industry, and also from Singapore, these countries that taken the lead in Asia, and also Japan, in how developing countries could learn from this experience. And I agree with you that, in the WtERT, we will, collaborate, like to bring a collective intelligence, to support developing nations and also universities to advance, waste to energy in terms of policies, technology, training, education. And I'm sure this WtERT Asia will be as a support for Egypt, bringing all the Asian countries, and not only Asia, but all the 20 countries around the world. And I think it is time. It is now to act and to work all together as, let's say, as an entrepreneur to move things forward.